Okay, guys, so here are in-class notes for 8.4b. We learned to set up our trigonometry equations. Now we learned to solve. So you should have already watched the 8.4b lesson on Canvas Studio. And this is what we hopefully tried on our own. Number 1 and 2 went over. Hey, we set it up. We're missing a side. One we multiplied. One we divided using proportions. What's going to happen now is we're going to go ahead and go over our inverse. What happens when we miss the angle? We went over number 3 and 4 on the video. The biggest thing, I keep stressing this inverse. You have to make sure that you are using the inverse, not the regular function. Let me get my calculator ready too so I can show you the differences of what happens. Okay? So, this is the very important thing. This is our finding a missing angle. If you have the angle measurement, 72 degrees, 83 degrees, 15 degrees, you do not use the inverse. It's when you have theta or you have an x in the angle. I asked you to do number 5 and 6 on your own. Let's take a look at this. Here's your reference angle. Here, across from my 90 degree, I do have H, and I also have right next door A. A and H is going to go with cosine, with our ka and SOHCAHTOA. So what we do is we set up theta is going to be equal to the inverse of adjacent over hypotenuse, 14 over 19. Okay, so then we go to our calculator, we plug that in, we're going to go to our function, and we're going to go to the inverse cosine, and then we're going to do back to main at 14, and you can just do divided by 19. We went around to the nearest whole number like we did with the others, so we're going to wind up with approximately 43 degrees. So theta will be approximately 40, oop, you can't see. All right, approximately 43 degrees. Okay, let me show you what happens if we don't do the inverse. Okay, I'm pressing enter so you guys can have that to compare. If I just go cosine of 14 divided by 19, this is so important. Look at the difference in those numbers. Huge difference. That's why you have to make sure that if you are missing an angle, you've got to go to the function and use your inverse. Okay? Number 6, reference angle. I do not have hypotenuse. Bam! Already know I am using TOA. I'm using tangent. No hypotenuse. Make sure that we go all the way across the opposite side of this triangular lake or pond, swimming all the way to the opposite side where we get 23. The angle and 18 are right next door. Here's their wall. They're right next door to each other, A. So we will do theta is equal to our inverse tangent of opposite 23 over adjacent 18. We're going to round to the nearest whole number. Again, just showing you again in the calculator. Function to our inverse tangent, back to main, 23 divided by 18. We're going to wind up with roughly 52 degrees. The other side of the video, I set all the pictures up for you, told you the stories. Gave you 4 different stories. Now we're going to go through and solve. Reference angle, 72 degrees. I have a measurement. I'm looking for a side. So we're going to do it just like normal, like number 1 and 2 on the video. Here, I have my hypotenuse, and I have right next door adjacent. So I'll be using ka, SOHCAHTOA, my cosine. So we do have an angle, so we're going to have cosine of that 72 is equal to, we have our A over our H, so we will have 11 over X. Now, shortcut with this, if you have X in the denominator, you're going to divide. So you can look at it as these two are going to switch places. X is going to move over here, and then the cosine of 72 is going to move to the other side, or to move down here. All you're doing is you're packing your bags, cosine of 72. You're packing the bags on X. They're going to switch places. Okay, that's all that's happening here. Or if you want to look at it as the proportion way, always want to offer you guys what you need. Here we set this over 1. We're going to find ourselves cross-multiplying cosine of 72. Sorry for the sloppy handwriting, trying to make it as short as possible. Times x is equal to, well, 1 times 11, 11. We have cosine 72 times x, sorry. We need to get rid of that cosine 72 by dividing both sides by cosine of 72. Canceling that out. So we're left with the x is equal to that 11 over cosine of 72. So you see we get the same thing. We're just switching, and then we divide. So we go to our calculator. All we're going to do is 11 divided by cosine, no inverse, of 72. We want the nearest hundred. So x will be approximately, this is the fun one, 35.6. What ends up happening here is that 6, we want to round to the hundreds, which is that 9, but that 6 afterwards bumps that 9 to a 10, making it that 0 that's over here. But that 10, you have to carry that 1 over to the 5, making it that 6. Unless we're dealing with money, you don't need that 0. Okay, remember your rounding rules, ladies and gentlemen. All right, next. Story's been told. Reference angle. I have my hypotenuse. I have to swim to the opposite side of my triangular pond to get that x, so we have O and H. This will be our sine. We have our angle measurement, so we're just going to set up sine of that 13 degrees is equal to opposite over hypotenuse, x over 3,600. When your x is in the numerator, you're just going to multiply. Okay? Again, looking at it from a proportional standpoint, this is just going to give you that x. And then you're going to multiply these two. As I stated in the original video, please, 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 always put the number first before the trigonometric function. So we want to do the 3,600 first times the sine of 13. I'll show you again what may happen if you don't. So here we take 3,600, don't even have to push multiply, sine of 13. We get 809, so x is approximately, we're going to round to the nearest hundredths again, 809 and 82 hundredths. Okay? If we do not put the number first, and I already saw this numerous times today, if we do sine of 13 first, and then we're in a hurry and we go times 3,600, look at the difference in those. This, what we have, the negative 14, means we have to move this decimal 14 times to the left, giving us 0.13 zeros, and then this number. That's a very small number. What's happening here is it is multiplying the degree of 13 times 3,600 before it does some sort of sine function in there. So the only way out of this is if you actually remember every single time to get arrow out of the parentheses. Don't do that. Just put the number first, please. All right? Number 9. Reference angle. Got it. No inverse. I do not have my hypotenuse. Ooh, got tangent. TOA. No hypotenuse. Always going to be tangent. Swim across the opposite side of that pond. Opposite. Right next door. Sharing that wall. Right next door we have our adjacent. So we will have the tangent of our degree 2 is equal to opposite x over adjacent 700. Shortcut here is we're just going to cross multiply these. So x will come out to number first times tangent of 2. Okay? Again, please use a Desmos because I had a student getting different answers than me, and it's because she used a different calculator and it was set in that radians I told you about. So always make sure this is defaults to degrees. 700, then we have to push times tangent of 2. This one didn't tell us, but in the video I told you round to the nearest hundredths. So x will become approximately, as you see on the calculator, 24.44. Lots of fours. Lastly, number 10. Down here, reference angle. Whoa, missing the reference angle. That tells us we have to do the inverse. Okay, we have no angle. We have to do the inverse one. So first, let's figure out what sides we have. I've got my hypotenuse across with a 90-degree angle, and then the 15 is on the opposite side of this triangular lake, swim all the way to the opposite side, so I'll be using sine. So here we will say theta is equal to the inverse sine of 15 over 60. If you would like to simplify this, you would have, you'll have theta equals the inverse sine of 1 over 4. You do not need to simplify. They will come out to the exact same answer. Okay? So back over here, I'm going to push my clear all. Go to my function so I can get my inverse. Inverse sine of, I'll just do the 15, go back to main, 15 divided by 60. Okay? Watch. Same thing here. Inverse sine of 1 divided by 4. Same exact thing. Okay? So this one threw us for a loop and said the nearest tenth. So theta is going to be approximately, so we see here, 14.5. That 7 moves the 4 up to a 5. 14.5 degrees. There you go. Make sure you get your exit ticket finished and submitted.